Okay, example 3. It says here that you inherited $5,000 with the stipulation that for the first year, the money had to be invested. Whoops. The money had to be invested in two funds paying 9% and 11% annual interest. So it asks how much did you invest at each rate if the total interest earned for the year was $487. Okay, so first of all, it's saying that we're going to get two chunks of money. Okay, so I mean, really, we got one big chunk of money. We got 5 grand. Okay, but the 5 grand had to get invested in two pieces. So let's call X the first chunk of money. So the first chunk of money is X, and let's say that was the one that got invested at 9%. Okay, now this is just for us to know. Okay, and then the other chunk of money we'll call Y, and that got invested 11%. Okay, now let's just think about what it says. It says that we had two pieces of money. One chunk of money. It was $5,000, but we break it into two pieces. So we're gonna. That means since we're breaking it into two pieces, those two pieces added together to get $5,000, because we took the $5,000 when we put it in two different investments. So that means when we add them together, we get $5,000. So if we took our first chunk of money, okay, and we invested that at 9%, so we took 9% of that piece of that chunk of money, and so 9% of X, so that means we have to take 0.09, we have to multiply it by X. Okay, and if we add that to 11% of our Y amount, then that is going to equal $487. So now, if all I have to do is just solve this, and let's use just the addition method again. I mean, I know I've been using that one a lot, but I use it mostly for these linear systems like this. So if I take the second equation, and if I first of all, how about I multiply the second equation by 100, because then I don't have any more decimals. So if I multiply this by 100, then my second equation becomes 9x plus 11y is $48,700. Okay, that's a comma. Okay, now since I'm going to try to use the elimination method, how about we just eliminate x? So how about I multiply this by negative 9, this whole equation. So then that means that this is going to become negative 9x minus 11y, and that's going to equal negative $45,000. So now if I add these two equations together, I'm going to get, I'm sorry, when I multiply this, I got negative 9x. This should be minus 9y, not negative 11. That's minus 9y. Yeah, that's a mistake. And so then that would equal, yeah, negative 45. Yeah, because the negative 9 you have to multiply by all the parts. I don't know why I did that. I think I was looking below it. Okay, so that's a negative 9. So if I add these, then this becomes 0 x's. This is going to become, if I take away 9 from 11, that's going to become 2y. And then here, if I do this subtraction, that's going to be like what? Is it $3,700? Is that right? 48, 45,000. You subtract them. 0,073. Yeah, $3,700. Okay, so 2y is $3,700. But now if you divide both sides by 2, then that means that y will be $1,850. Is that right? Yeah, that's right. So $1,850. will be our amount that was invested at 11%. So if that amount was invested at 11%, then that means the amount that was invested at 9% should be $3,150. Okay, and the reason I know that is because remember our first equation said that if you take x and y, you add them together, you get 5,000. So that means since we found y was 1850, if you take x and you add 1,850 to it, and you get 5,000, then that must mean that if you subtract 1850 from both sides, that x would be this 5,000 minus 1850, which would mean that x would equal 3,150. Okay, so that's why we get this. Okay, now let's think about the interpretation. Okay, because again, we wouldn't want to put this as an ordered pair here because I mean it wasn't originally a problem like that. If I ask you, hey, if I read you this problem and I said, okay, you inherited 5,000, you broke them into two pieces, and you tell me, well, hey, like x is this, y is this. I'm like, well, what is x and y? So you have to spell it out. So we want to say that that 3,500, or sorry, $3,150 was invested at 9%, and 1,850 was invested at 11%. Okay, let's look at the next problem. Okay, this problem says that a chemist needs to mix 12% acid solution with 20% acid solution to obtain 160 ounces of a 15% acid solution. So how many ounces of each of the acid solutions must be mixed? Okay, so basically what we're saying is we're saying X is going to represent the this is going to be the number of ounces of the 12% solution. Just think about it. Okay, we're going to mix some amount of 12% solution. We're going to mix a different amount of 20% solution, and when we're done, we want 160 ounces, and this concentration needs to be 15%. So X is going to be the number of ounces of the 12%, solution. Y is going to be the number of ounces of the 20% solution. Okay, so then that means, let's think about this. We know at the end we need 160 ounces. So then that means that X plus Y must be 160. Okay, now why? Well, because X represented the number of ounces of 12%. Y was number of ounces. So if you take number of ounces and number of ounces, you add them together, we've got to have 160 ounces only. Okay, and then we're going to do, this is going to be very similar to the last problem. We know that 12% of the X solution, this is how much, like we want to think about our concentration. It's going to be 12% times the amount of that 12% that's added. Okay, and then we're taking a 20% and we're taking some amount there. So it's an amount times a percentage, an amount times a percentage. But at the end, we want a 15% solution, and the amount that we're going to have is the 160. Okay, now I don't know what 160 times 0.15 is offhand, which is right off the top of my head, so I'm just writing it as 0.15 times 160 for now. Okay, and so that's why that's set up that way. Okay, so if I take this same kind of technique, and how about I multiply the bottom equation, just like in this last one I did, multiply it by 100, then that the bottom equation now becomes 12x plus 20y is equal to 15 times 160. So 15 times 16 is going to be, let's see, 225, but we want to add an extra 15 on that. So 240, yeah, 240 with a 0. So yeah, I think that's right. And then so let's use elimination. So let's multiply this top equation by negative 12. Okay, and again, remember I took this equation. I'll say put in brackets. I took this equation and I multiplied it by 100, so I didn't have decimals. Okay, so then if I take negative 12 multiplied by the top equation, I'm going to get negative 12x minus 12y, and that'll equal, let's see, 196 minus 4, 192. With a 0, I think. I think that's right. That's a 0. Yeah, so that's right. I got it right. Okay, so now if we take these two equations and we add them together, and let's see, then this will become 8y, and then this becomes, wait, did I forget to, I think I forgot to multiply by a negative. This is going to be multiplied, this is negative. See, again, don't make the mistakes that I did. Okay, this negative 12, it's got to be multiplied by every single part. So all these have to be negative. I can tell because it would make sense that it would be a larger number. So if I take this and I subtract 1920, then I'm going to get, okay, this is a 3, that's 8, and then 480. Okay, and if I divide by 8, then I get y is equal to, is it 60, I think? Yeah. So that means the number of ounces of the 20% solution is 60. So that means the number of ounces for the 12% must be 100 because they have to add up to 160. So that means, x has to be 100. For that same reason, because here it says x plus y is 160. If y is 60, then x has to be 100 because 100 plus 60 would be 160. And again, you could just tell by subtracting off. Just take off 60 off both sides, and you'll get x is equal to 100. So then that means that that's the amount, and so then you could just say the number of ounces of the 12% solution is 100, and the number of ounces of the 20% solution is 60, and then that would be our answer. You can go back and check, but that's going to be our answer. So I hope that makes sense, and that's kind of how we do these application problems.